I am Ganitha Acharya, a proud Indian mathematician. Mathematics is not just a subject, it's the language of all sciences. It helps us explore and develop physics, chemistry, astronomy, and the natural world, and drives innovation in technology. From simple arithmetic to geometry, math guides us in the practical tasks of our daily lives.
Many of the mathematical principles, concepts, discoveries, and inventions have been created or developed by Indians much before these were popularized by the Western mathematicians, getting the undeserved credit in the process for their creation. The aim of this video is to establish this fact with proofs and references for the world to know the truth and restore the glory and credit back to India, that is,
Bhaarat.
In this video, we bring to you the top 15 such mathematical discoveries and inventions by mathematicians of
Bhaarat
that have revolutionized not only mathematics, but science, technology, and everyday life forever. We have ranked them and presented them in the increasing order of significance. Video Part 1. Rank numbers 15 to 9 of Top 15. At rank number 15 is quadratic equations. What are quadratic equations? They are algebraic equations of the second degree, generally written in the standard form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers, and a is not equal to 0. The solutions to a quadratic equation, called roots, are the values of x that satisfy the equation. There are always and only two roots, which may be real or complex numbers. Why are they important, and how are they useful? In physics and engineering, two model parabola paths of projectiles like rockets and missiles, design safe, efficient bridges, arches, and curved structures, create parabolic satellite dishes, headlights, and telescopes to focus and reflect waves. In business and economics, two optimize profits, costs, pricing, inventory, and markets. In science and nature, two model population growth of species. In everyday life and sports, two shape smooth highway ramps, tunnels, and roads for comfort and safety. Calculate speeds, distances, and times under uniform acceleration. Estimate trajectories in ball throws, fountains, or curved designs. Though the great Indian mathematician Aryabhatta I, who lived from 476 to 550 CE, initiated work on solving quadratic equations with an arithmetic perspective and geometric reasoning, it was Brahmagupta, who lived from 598 to 668 CE, who introduced more advanced algebraic techniques, formalizing the solution of quadratic equations with systematic methods and lemmas. These are detailed in his seminal work Brahmasfuta Siddhanta of 628 CE, as per the summary shown on your screen. This corresponds algebraically to this familiar quadratic formula, as shown now. Brahmagupta invented this formula centuries before Euler and Lagrange, who rediscovered Brahmagupta's lemmas in late 18th century CE. The concept of infinity was first mentioned in the famous hymn, the Shanti Mantra, starting as
Purnamadav Purnamidam,
which appears in the Isha and Brihadaranyaka Upanishads, which are part of the Shukla Yajur Veda, dated at 2500 BCE, or 4,500 years ago. Its meaning, that ultimate reality, or Brahman, is infinite or complete. This manifested observable universe is also infinite or complete. From the infinite comes forth. That is, the universe emerges from the Brahman. When the infinite is taken away from the infinite still remains. That is, the infinite nature of Brahman is not lessened by the emanation of the universe. It remains eternally whole. Much later, in the 6th century CE, the concept of infinity was proposed by the Greek philosopher Anaximander, who used the term apeiron, meaning unbounded or indefinite, which can be interpreted as infinite. Later, Aristotle in the 4th century BCE distinguished potential infinity from actual infinity, mainly rejecting the latter. Thus, Indian rishis knew of the concept of infinity almost 2,000 years before Greek philosophers. The Indian mathematician Bhaskara II introduced the mathematical concept of infinity as 1 divided by 0 in his work Siddhanta Shiromani in 1150 CE. Mathematically, the symbol for infinity was introduced much later by John Wallis in the 17th century. The mean value theorem, popularly known as Rolle's theorem, forms the basis for differential calculus. Bhaskara II, in his famous work Siddhanta Shiromani of 1150 CE, demonstrated an early understanding closely related to the theorem. He stated that at an instant, when a planet is at its apogee or highest point, or perigee or lowest point, its instantaneous speed is 0, even though its overall motion is non-zero. Thus, he indirectly showed that when a variable attains a maximum or minimum value, its differential or instantaneous rate of change is 0. Bhaskara's work is recognized as an important precursor to the mean value theorem and concepts akin to differential calculus, but he did not develop the theorem in its complete modern form. The formal mean value theorem, as known today, was later stated by Parameshvara, a prominent mathematician of Kerala, in the early 15th century in his Leilavati Bhasha, a commentary on famous mathematical treatise, Leilavati. However, the credit for the theorem is wrongly given to Michel Rolle, a French mathematician, as his invention in 1691 CE. We hope you are enjoying this video, brought to you by the Unknown India channel that tells you all about India, that is Bhaarat, that you did not know. Please like this video, share it with your contacts, subscribe to the channel if not done already, and hit the bell icon to be notified of new videos. In the number series 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on, where each term is the sum of the previous two terms, the ratio of two successive terms tends towards the value of 1.618, known as golden ratio. It is unique because it describes a proportion where the ratio of the whole to the larger part is the same as the ratio of the larger part to the smaller part. This relationship creates a sense of balance, harmony, and aesthetic beauty that is found in nature, art, architecture, and mathematics. It appears in many natural forms, such as the spiral arrangement of leaves, shells, sunflower seeds, pine cones, and galaxies. It is also found in the proportions of the human body and in the structure of plants and animals, reflecting efficient growth and energy distribution. Though this series was discovered by an Indian prosodian, mathematician, and scholar Acharya Pingala in the context of meters for Sanskrit poetry around 200 BCE, the credit for its discovery has been wrongly given to Fibonacci, an Italian mathematician, who popularized it only in 1202 CE through his famous book Liber Abaci. In its introduction, he has stated that he based his work completely on Indian methods while adding some of his own contributions. Despite this sequence or series is known by his name. Combinatorics is a very important branch of mathematics that is useful in daily life, business, entertainment, and information technology. Acharya Pingala, the ancient Indian prosodian of 3rd century BCE, pioneered work in combinatorics through his study of Sanskrit poetic meters in his famous work, Chanda Shastra. He discovered a systematic way to enumerate all possible combinations of lagu, or light, and guru, or heavy syllables, in a meter of given length, n. This is effectively an early form of combinatorial enumeration, using recursive algorithms to generate binary patterns representing these syllable structures. Thus, Pingala's discovery of combinatorics was both a mathematical and linguistic achievement that introduced systematic, recursive counting methods. The number of possible combinations, when we choose r things or objects from a set of n items, is given by this formula, which was invented by an ancient Indian mathematician, Mahavira, in his book Ganitha Sara Sangraha, written in 850 BCE. He explains this formula in a verse. But the credit for the combinatorics formula is wrongly given to two French mathematicians, Blaise Pascal and Pierre de Fermat, who lived in middle of 17th century CE after nearly 2,500 years of the Indian discovery. infinite series for trigonometric functions have enabled making an algebraic rather than only geometric interpretation of these functions, like sine, cosine, tan, etc. These have also been very useful in vast improvements in the computation of trigonometric functions, extension into complex and abstract domains, and applications across many scientific fields, such as acoustics, optics, electromagnetism, electronic oscillation, quantum mechanics, statistics, etc. In the 14th century, a brilliant Indian mathematician and astronomer called Madhava Nambudri of Sangama Grama, near Cochin in Kerala state of India, had discovered these long before the invention of calculus. He had also made several original contributions to the other branches of mathematics, but this discovery is wrongly attributed by the Western world to Sir Isaac Newton for sine and cosine functions, and to the German mathematician Gottfried Leibniz for arctan function. Both of them lived from the middle of the 17th century to early 18th century of CE. An arithmetic progression is a series of numbers with constant difference between consecutive terms. It has myriad practical applications. For example, in finance, for calculation of interest and budgeting; in architecture, for design of ramps and steps with constant rise; in everyday life, as in auditorium seating; in physics, for modeling motion at constant velocity or acceleration; in population growth modeling and urban planning; in sorting and searching algorithms in information technology. The arithmetic progression of odd numbers from 1 to 33 appears in the popular and sacred hymn Sri Rudraprasnam's Chamakam section, which is part of Krishna Yajurveda, dated to 2500 BCE. The progression of even numbers and series of multiples of 10 are presented in Yajurveda. All these prove that Indians knew about odd and even decimal numbers 4,500 years ago. We have a separate video on this dating, as per link given below in description. However, the discovery of arithmetic progression is wrongly attributed to the Egyptians, quoting the Rhine papyrus of 1650 BCE, which came about much later. Rank numbers 8 to 1 of top 15. To be continued in video part 2.